Welcome. Today we are diving into one of the biggest, most important shifts happening in tech right now, the rise of embodied AI. Now, this isn't just about AI that can think, it's about AI that can do. We're talking about AI that can see, reason, and actually act in the real physical world. This is the moment the digital revolution finally gets a body. And for anyone watching the markets, this changes everything.
And this quote from NVIDIA CEO Jensen Huang just sets the stage perfectly. For anyone paying attention, a statement like that is a massive signal of a huge inflection point. We're talking about a move beyond just small improvements to a total transformation in what machines are capable of, and it's all being driven by what's now being called physical AI.
So here's how we're going to break it all down. First, we'll nail down what this ChatGPT moment really is. Then we're going to look under the hood at the AI brain and the hardware body that makes it all work. After that, we'll follow the money, see where it's being deployed, and then tackle the very real hurdles and risks. We'll wrap up with the investment horizon. Let's jump in. All right, first up, what exactly is this ChatGPT moment for robotics? Well, it's about a completely new class of machine. This isn't just about making a factory arm a little bit faster. We're talking about creating robots that can operate with a kind of general intelligence out there in the messy physical world.
This slide really breaks down the core difference. On the one hand, you've got your classical robots. They're amazing at doing one single thing over and over in a perfectly controlled environment. But on the other hand, you have embodied AI. This thing is a generalist. It learns from huge amounts of data. And the key part? It understands natural language. You can literally just tell it what to do, and it figures out how to turn your words into physical actions.
So how does this new breed of machine actually think? Well, the magic is really in the new AI brain, something called a Vision Language Action Model, or VLA for short. And this right here, this is the core software innovation that's driving this entire revolution. A VLA is one single unified neural network. It takes in what the robot sees through its cameras, it understands a command like, hey, pick up the red cup over there by the keyboard, and then it generates the exact motor commands to go and do it. The model already knows what a cup is, it knows what red looks like, all from its training on internet data. That's a massive leap from having to program every single object and every single action from scratch. And this just shows you the trend perfectly. Just like we saw with large language models, these VLAs are scaling. And man, they are scaling fast. We went from models like RT2 at 55 billion parameters to the prediction that we'll be seeing models over 100 billion parameters this year. This kind of scaling is where all the new, surprising capabilities come from, and it's a huge flashing signal for future performance gains.
But a powerful brain is pretty useless without a capable body. And that body needs its own special computer, not somewhere up in the cloud, but right there on the robot itself. And that brings us to the absolutely critical role of new AI hardware.
Just look at this leap in only one generation of hardware. Comparing the older Jetson Orin to the new Blackwell-based T4000, you see a massive jump in performance. But honestly, the really crucial part here is the memory bandwidth. Running these gigantic new VLA models right on the robot is all about how fast you can move data around. And this new hardware is built to tackle that exact problem, with up to 4 times the memory bandwidth of what came before.
And here's a real, concrete number for you. At volume, the little module that enables this whole next generation of robotics costs just under $2,000. That makes this kind of advanced, on-device AI compute accessible for really wide-scale deployment, which is, of course, a key ingredient for market growth.
Okay, so the tech is moving at lightning speed. But where is the money actually going? Let's shift our focus to the market and see how this stuff is actually being put to use in the real world.
Right now, one of the biggest drivers is defense. With everything shifting in geopolitics, investment in defense robotics is predicted to grow by at least 100% year over year. That level of government investment is a powerful accelerant, It pushes the technology forward for the entire ecosystem.
But that raises a pretty fair question, right? We see all these incredible YouTube demos of humanoid robots. So where are they? It's really important to separate the long-term vision from what's actually happening commercially today.
And this chart puts it all into perspective. By 2026, the number of deployed mobile robots, in warehouses and factories, is expected to outnumber commercial humanoid deployments by at least 10 to 1. So yeah, while humanoids like the ones at BMW get all the headlines, the immediate, scaled commercial opportunity is still in mobile manipulators doing high-volume, repetitive tasks.
Of course, no big platform shift like this comes without challenges, and acknowledging the risks and the reality on the ground is just critical for any serious analysis. This is where the rubber literally meets the road.
These 4 categories from some recent research really summarize the landscape well. You've got the obvious physical risks of harm, informational risks like mass surveillance from all these mobile sensor platforms, major economic risks like labor displacement, and then these deep social risks like bias and a complete fog around who's accountable for what.
And these risks, they are not just theoretical. This timeline shows that safety incidents are already happening, and they're getting a lot of public attention. From viral videos of near misses to massive lawsuits over industrial accidents, the scrutiny on robot safety is only going to get more intense, which you have to imagine will lead to a regulatory response.
And this brings us to the central, completely unanswered question. When a truly autonomous system, one that learns and adapts on its own, causes harm, who is liable? Is it the manufacturer, the software developer, the owner? This massive legal and liability gap is one of the biggest unsolved problems for the entire industry, full stop.
Okay, let's bring it all home and distill this down into the key takeaways for anyone looking at the investment horizon for embodied AI.
So, here's the path to deployment in a nutshell. Step 1, the tech shift of these VLA models is absolutely real and it's speeding up. Step 2, the hardware needed to run them is catching up fast. But step 3, the gap between a flashy demo and a truly reliable system that you can deploy at scale, that gap is still really wide. And step 4, bridging that gap means solving these immense challenges of safety, liability, and regulation. And for investors, those hurdles are both the biggest risks and probably the biggest opportunities.
Which leaves us with this final thought. The platform shift is happening. There's no doubt about it. But where will the value ultimately be captured? Is it going to be the companies building the physical robots, the ones designing the specialized chips, or the providers of the foundational AI models themselves? That right there, that's the billion-dollar question for this new era of embodied AI.